Right, in this video, we're going to look at the properties of acids, right? So, I have three pieces of paper. I have red litmus paper, I have blue litmus paper, I have cobalt chloride paper, and I'll get another paper. And then now I have pH paper, which measures 0 to 14. Right, and for acids, as you can see here, for acids, it is 0, right? This is strong acids. It will have a pH of 0, 0.1, not 0.1, 1, 2, 3, 4. So if you say I put this paper in it and it changes to red, you know it's a strong acid, right? So 4 pieces of paper, and we're going to see how the acid, and by the way, in this test tube rock, we have hydrochloric acid present. And we know that hydrochloric acid is a strong acid. All right, so let's start off. We have the red litmus paper, and you should know, right? You're doing chemistry. So this is red litmus paper. If this is truly an acid, then you should know what will happen to the red litmus paper, all right? So, if you notice, all right, nothing happened. So, you should know if that is correct. Then now, I'm going to use my blue litmus paper again. You are doing chemistry, you should know what color change to expect. Alright. So there we go. That's blue litmus paper, change in color. So the first one was red litmus paper, blue litmus paper. This one, the third one now, is cobalt chloride paper. So this was red litmus paper, nothing happened. This was the blue litmus paper, all right, change to red. And then in this one now, I'm going to put cobalt chloride paper, all right. And here we go, that is what happened, sorry, to the cobalt chloride paper, all right. So let me go again. This is cobalt chloride paper. Now this is how it looks. All right. This is blue litmus paper. This is how it looks when you place it in the hydrochloric acid. So blue litmus paper in hydrochloric acid, this is what happened. Red litmus paper, this is what happened when you put red litmus paper in acid. All right, okay. All right, so this is, as it says, this is pH paper, right? And it records from a pH of 1 from 0 to 14. All right, so from 0 to 14, and it has the color codes, right? So you know that 7 is neutral, that has a green color. Then it gets a little darker green, then blue, almost purple. But on the acidic side, it's kind of yellow, orange, red. So the stronger the acid, if it's a strong acid, it will be red. If it's a weak acid, it will have an orange color, closer to yellow. All right. So this is the universal. This is the pH paper, measures from 0 to 14. If hydrochloric acid is a strong acid, then it should measure close to 1, right? So if this is hydrochloric acid, we're expecting a red color. And that is the, let me show you again. When it's red, 0 and 1. Only a strong acid will change it to this color. So we can see that it's hydrochloric acid. All right. All right. So with that out of the way, we are going to do some reactions now of the acid. So we know that acids react with metals to form salt and hydrogen gas. So here I have magnesium ribbon. So metals react with acid to form salt and hydrogen gas. Now if it's hydrogen gas that is being produced, when we light this splint, if we place it inside the test tube, you should hear a pop sound and it out. Alright? So we have our acid. Let me bring it back into focus. Alright. This test tube. Alright, let us place our magnesium in it. Alright, also let me light this on this end. Hold on. I hope you heard that. I want the gas to out it and not me bouncing it. Alright. More gas supposed to be in there. So I'm going to slowly place it inside. Alright, slowly. And it out. Alright. So I hope you heard that pop sound. As you can see, it is still. Alright, so continuing, right? So that happened. The test tube, it's actually hot. That's my bad. When metals react with acid, the reaction is exothermic, so heat is produced, right? So a lot of heat was just produced, so the test tube, it got hot. Well, too hot in this case. Right, so when metals react with acid, we get salt and hydrogen gas. We test for the hydrogen gas by using we call it a wooden splint, so the piece of stick, right? It's a wooden splint, and as I hope you heard it, it out with a popping sound, right? So fission occurred, or we can say effervescence, right? Because it was very vigorous. So when the reaction is vigorous, we say effervescence took place, right? So it was vigorous. Once you see bubbles being produced, that's a sign of a gas. So to prove that it is hydrogen gas, I placed the lighted splint at the mouth of the test tube first. You hear it with the pop sound. That's characteristics of hydrogen gas. And when I placed it further down where more of the gas was, you saw that the splint was out, right? So that's sign of hydrogen gas. Now the next reaction will be with sodium carbonate. Now when acids react with sodium carbonate, you will get salt, carbon dioxide, and water. So we are going to see how acids react with carbonate, but also we are going to test if carbon dioxide is being produced. Now, if you want to know if carbon dioxide is being produced, we use a solution of calcium hydroxide, right? Now, I'm going to attach this side of the test tube, this side of this delivery tube to this test tube, right? I'm going to place the sodium carbonate in this test tube. So sodium carbonate plus the acid, it is going to produce carbon dioxide. It's a gas, so it will leave. But before it can leave, I'm going to place this over it, right? So it should travel through this tube and go into this test tube with the calcium hydroxide, right? Now once you see a white precipitate, once you see that color change start to occur, once you start to see it get white, right, it's a sign that carbon dioxide is being produced. All right, so okay, let me do this quickly. So let me get this, the sodium carbonate, just a second. Alright, I'm going to add this sodium carbonate. As you can see, it is also fizzing, right? But I placed it over it a little late, so I'm going to add some more, all right? So let's wait a little. All right, so we're going to try it again and see if this time we can move a little faster and cover it quickly. Remember, we are, if you notice, let me carry it closer. If you notice, it starts to get white, right down here. So the carbon dioxide is dissolving or reacting with the calcium hydroxide. So it was colorless before, and as you can see, so let me add some more again. If we have excess acid, the reaction will continue. So let's add a little more sodium carbonate. All right, cover quickly. And definitely you can see it now, right? You can definitely see it. We have the white precipitate being formed. So it looks a little too cloudy, right? That's because the white precipitate is being formed. And you should know what that white precipitate is, right? When you react calcium hydroxide with carbon dioxide. So this is a test for carbon dioxide gas. If it is present when you add it to the calcium hydroxide, you should get a white precipitate, right? So that's good. Carbon dioxide is present. So it proves that when carbonates react with acid, you get carbon dioxide.